There's no visibility.
Yeah, looks like we got low visibility, so wind, snow. Whoa. So let's talk about batteries. Okay, so let's look at what we got here. This is the power pack that's sold in Canadian Tire, and it's it's rated 1600 amp. That's a boost rating for boosting your car, but its capacity is 28 ampere hours. And this thing's nice. It's got all kinds of features. It's got a lamp on the front here. It's got AC power. It's got USB power. You can switch everything on or just USB. This is the LED. This is the light LED on off, and it does capacity measurement, so we can see it's 100%. And it will alarm when the battery's low. And reading the manual, the battery alarm will go when the voltage drops to 11 volts. So that's basically your 12 volt battery is fully charged at 12.7 volts, around there, 12.6, 12.7. And according to these guys, they decided to put the alarm at 11, and which is fine. We'll look at that on a chart, and that'll save the battery. So what I have here is this is a marine deep cycle battery that's 65 ampere hours, so more than twice the other one. And this one I have because when I added heaters to my rig, it was drawing a lot of power, so I added this. And this thing can be paralleled up with a booster cable that actually plugs into the side here. And so then the power pack basically does all the voltage monitoring, and I can have AC out. Sometimes I plug my laptop into there, but usually I draw my DC power from the lighter socket. So it's great, but but nothing. It works very well. I have to turn this on. I guess the but was I have to turn this on so that it monitors the level of the battery, even though I don't draw any power from that. Usually I'm just drawing power at the side here, which is pure DC right to the battery. And so the two combined, of course, has almost 95 ampere hours of capacity. So what I'm going to do is they're fully loaded, they're fully charged, and I'm going to take this voltmeter and show you what fully charged looks like. So yeah, let's do that. So if I plug this into the side here, there I can put red on one and black on the other. You see 12.8. Now this is completely unloaded battery, virtually no drain. So that's really full, because 12.7 is full on the chart. And if I look at this guy, this is maybe a little more awkward. Let's see. Okay, 12.8. So there you have straightforward, fully loaded, completely unloaded, fully charged 12.8 volts. So that's your standard lead acid, standard lead acid battery. So we're not going to get into all the fancy stuff like lithium batteries and stuff like that. They've got their own purpose. They're very expensive. Yeah, they're lighter and have a lot of power, but they're very expensive. They're like 4 times the price of this stuff, maybe 3 or 4 times. So I'm not using those. Okay, so what do we got? I charge with good chargers. This is only a 3 amp charger, but it's able to cycle the battery through proper charging curves and give you a good charge, and it will also maintain it. And this power pack is built in with its own charging system. It's got a little adapter for AC, and it also charges up to very good charge. So that's an important thing, is you get a battery, you want to have a good charger. It doesn't have to be high capacity. This is only 3 amps, but you want it to be able to charge using charge curves where it will cycle your battery and give you a good charge, and maybe even repair your battery if you just discharged it. So and that could happen. One of the reasons why I've got all this, now I have like a little monitor here. A little thing I bought, and I can see 12.7 amps, 12.6. It's got a green light, so it's showing a good charge. What happened was I was hooked up. This big battery was in parallel with my power pack, and everything was going. I set my scope and let it go for the night, and then I got it in the morning, and it was absolutely dead to the world. And I wondered what happened. So what happened was there's a fuse in here. I can't get it out that easily, but there's a fuse in there, and that fuse blew. So I still had power coming out of here, but I didn't have my parallel power here from this big battery. So the fuse cut the load, because this is an input-output basically. It's mainly an output for jumpering, but it also provides an input from the backup battery, which if you want to put them in parallel. So the fuse blew, and that input was no longer connected. So I had a 28 ampere hour battery in my rig, and it had heaters on. My guess is it's operating about 4 amps. I see 3 amps on the monitor, but there's probably another somewhere under an amp that's being drawn by the mount, which is directly connected here. So I'm not able to measure the power when it's operating. And the alarm, if it was there, it would come on to protect it, but I didn't have the alarm on at the time. And so now I put this thing on, and when power is drawn, it will alarm when the battery's low. So anyway, what I'm going to do here is I'm going to set up a load. I have this light, and I'm going to set it up to draw some power. Now, lights these days are more efficient, so this is only going to draw 13 watts, maybe an amp. And I would have liked to draw 4 amps, but we'll see how the battery behaves anyway. So I'm going to plug this in, turn this on. There we go. Got my load. And let's see, let's put this aside. It won't get hot. This thing won't get hot. And we can look at the power being drawn. Well, maybe we can't. It's supposed to give me output, but it's using, I guess, too little. The power drawn is too little. So it doesn't show anything. But let's see what the voltage looks like. Remember, we're at 1 amp. So that's about a 30th of its capacity. Let's see. Where's my, there it is. Okay, now we're at 12.5. So no load, fully charged was 12.8, and now we're at 12.5. And if we look over here at 12.5, and he said 1/30th, so it's between these two curves. So you can see we're right about here. Now it says 60% state of charge. Let's see what, let's leave this like this, and then we'll see what the charge is when the alarm goes off. And what's our time? Our time is 3:04. Okay, I found a better load. I took out this bulb and I found myself a incandescent bulb, 60 watts. I'm gonna put it here where it's not gonna get too hot. And 60 watts, and it's drawing, it says 30 watts, 30, 40 watts. Okay, good. So that'll discharge the battery at a better rate, and we'll see how long it lasts. So it's only, let's see, 320. So it's been going for about less than 15 minutes, and I've just switched the load. And then let's see what the voltage looks like. .3. Okay, the alarm's going off. So let's see what the voltage is. .1. So as promised, approximately 11 volts, the alarm comes on. And I've been drawing 40 watts, which is close to the load of my rig with everything, I think, because that's a little under 4 amps. And that's about the same as my rig. But the thing is, it's at 11.1, and it's only 5:15, so that's only 2 hours with this 28 ampere hour battery pack. So I'm gonna stop this, and then I'm gonna let the thing settle, and then I'll find out how much power it has left in it. Okay, so let's see what the voltage is. The reason I say you have to wait for it to stabilize is because the battery has to kind of settle after power has been drawn, and then you can make a proper measurement of its capacity, of its charge state. Okay, so now it's saying 12 volts. So 12 volts, and let's see what this says. It says it's 0. And that's what I usually find on this thing. Once it's been used, it always says 0. So 12 volts and 0. So we can see what that looks like on the chart. Okay, let's look at the chart. 12 volt lead acid battery state of charge versus voltage while under discharge. And on the right, we have the discharge rate, and C by 100 is a low rate. And so you could, as you approach 0 discharge rate, you approach basically no load, and it can show your fully charged voltage at 12.7, 12.8. But so the chart's showing you the battery voltage while under discharge. This is your state of charge. So you can know your state of charge based on the voltage you see here that you measure, but that is dependent on your discharge rate. Okay, and the way the discharge rate is defined here, C over 3, for example, is the capacity divided by 3. Or so capacity is measured in ampere hours. So for example, I have a 28 ampere hour battery. Let's call it 30. So C divided by 3 would be 10 amps. So and C divided by 10 would be actually 2.8 amps. Now my rig takes something like 4 amps, and so that works out to C divided by 7. So I'm somewhere between this 10 and 5 here when I'm operating my battery. So if I operate the battery, say halfway between 10 and 5, and the alarm goes off at 11, I'm going to be down at 10% of power left. And so when I measured the voltage after battery stabilized, we saw that it had 12 volts. So, and this top curve is basically no load. So that's at 12 volts, we're also showing about 10% state of charge. So that lines up with the fact that it was drawing at the C7 rate here, and the alarm went off about this point here, 10%. But it only lasted 2 hours, and according to the rating, it should have lasted about 5 hours. So I don't know what's wrong with my battery, but it is a few years old, and it has been discharged completely to zero virtually a few times. So maybe that's the reason for that. So it won't go that long, 2 hours. So that's where my heavy duty battery comes in. This will keep it going all night.